Hello guys, let's start our DSA journey with this amazing visualizer by ChaiCode.com at dsa.chaicode.com. Use this link to get a 7-day free trial. Okay, let's start with the DSA, and today's question is top k frequent element. Okay, given an integer array and a number k, return the k most frequent elements. The answer is guaranteed to be unique. It may return in any order. Okay, so this is the tags. Let's just take this example. Here, one thing also mentioned, that is k equal to 2. We have to find two elements with the most frequency. Okay, two elements like most frequency and the second most frequency. Okay, so in this array, 1 has 3 times, 2 has 2 times, so our answer would be 1 and 2. Why? Because we have to find two most frequent element, and 1 is the first and 2 is the second. Okay, in this array, so 1 and 2, this is our question. Okay, so let's first visualize it. Okay, first take a store count and number and their count. Okay, let's just take it here. So this is our array. Let's just take a map, store the number and the count of that number and count of that number, both are integers. So we just take an int here and then again int here. Okay, so the one has a count of 3, 2 has a count of 2, 3 has a count of 1. Okay, now sort this on the basis of this count of the on the basis of this count value, also in a decreasing order. Okay, count or frequency, whatever you want, and just return these two value because k is 2 here. Okay, so same thing we can show here. Return two most frequent value of the array. First we need to know how often each value appears. That's mean we have to first calculate the value and the count of that value. Okay, so in the count map we can use, we just take 1 at once, 2 1 as 2, 1 as 3. Okay, now again we increase it, and 1 now 2 has 1 time, 2 has 2 times, then comes 3. So this is our final map: 1 3 times, 2 2 times, 3 1 times. Okay, then sort these entries, which is in a order where the most frequency element comes at first. Okay, we just sort it here like 1 3, because the 3 is the greatest one, so we should put all the greatest element at the starting and then going decreasing one by one. Okay, then the result would be first kth value, so take the k to 1 and 2, these two are the values. Okay, so let's write the pseudocode here. We are given a function with array, take a map which is nothing but an empty map of number and frequency, of that number. So now perform a for loop from the starting to the end of the array. For every element, first store the frequency or the increase the frequency of the element for every element. Okay, now just go to the next and sort the map in the decreasing order. Okay, we can store the map in a vector or anything. We just sort the map in decreasing, okay, decreasing order of frequencies. Decreasing order of frequencies. Okay, basis of the frequency, we just have to put it in a decreasing frequency. Okay, at the end, take the answer, which is the first k values of the map. Okay, first k values of the map. Now, just return the answer. Okay, now let's go to the question and write the code for the question. So this is our pseudocode. First, take a map, or first take the size of the array, then take the map. Let's take an unordered map. Take an unordered map, number and the frequency. So int and int of MP. First we have to just put the value to the or the frequencies to the map. Okay, so for that, use a for loop in starting from 0 till the end, and just so from here we just get all our frequencies stored in this map. Now we have to sort the map, but before sorting the map directly, we should go and insert it into a vector, because sorting the vector is comparatively easier than sorting a map. So vector of pair of int. So why frequencies? So why pair of int? Because in the map we are taking the number and the frequencies. The number and the frequencies in the map. So in the pair we are taking the same thing in the frequency, the same, the number and the number and the frequency of the number in this frequency vector, which is nothing but a pair of pair type. So now sort this, but we have to sort it in a decreasing manner. Okay, so frequency dot start, okay, not start, frequency dot begin, and frequency dot end. But we have to give here is comparison function, and the comparison function would be, we have to create a comparison function here, like static bool p, just take two pointers, two values of the vector, like here our pair is the value, so pair of, so this all the pair, because this vector store only pairs of integer, we just put pairs of integer and integer here. Okay, this is a value of the vector, this is also a value of the vector. On the basis of the second index, on the basis of the count, we have to return. So return a dot second is greater than b dot second. Okay, so after doing this, we achieve a state where this pair or the vector, the pair, the frequencies are sorted in a decreasing order on the basis of the frequencies of the element. Okay, now just create an answer here also, which is nothing but vector int answer. Now just move a k loop. Okay, just move a k loop because we have to store all the k numbers. So k numbers, we are storing k numbers. So store all the numbers in the array. So the first value would be the biggest value or the most frequent value always be at the starting index of the vector, because we just sort it here. The vector would be simply like 1 3, then 2 2, then 3 1. So the vector would look like this. So we are taking a loop from the starting to the kth value. So we just take the first value, the second value, the third value till the kth value. So just put here that frequency of I, or the index which we are happening dot second. Sorry, not second, it should be first. So because the first stored the value and the second stored the count or the frequency of the value, and we only need this value. Okay, so at the end just return answer. Oh, we missed a semicolon. Runtime error. Null pointer type. Okay, where is the problem? This is okay, this is okay. Of second is greater than a of b of second. This is okay. Should we have to return it? Okay, okay. Let me check. We forget to push all the value to the array. Just frequency dot pushback of it. We don't push any value. We point all the things to the null. That's why we are getting that null pointer error. Yes, it's working. Okay, 583. That's great. And in this position, in this step, we are just taking, you can say here like O of n log n time, and the space is O of n, because we are just sorting this value which is take n log n time, and everything is n because this is just a loop which is size n, and we are using another vector which is a frequency, also a map here which take big O of n space. That's why big O of n log n time and big O of n space. Okay, now let's go to the optimized approach, which is a bucket sort approach. approach. Okay, so first of all, what is a bucket sort? Let just simplify it. In bucket sort, we have some buckets like this. We have some spaces or buckets or anything that we have, and when we found any element that suits in this bucket, okay, for suppose this is 1, this is 2, this is 3, this is 4, this is 5, this is, and we just going through, and let's, and when an one element just suit is in this bucket, we just go take a pointer and just point it here. In the second, we just put second. In the third, we just put a third here. So if you see this all the things are in a sorted way. Okay, so we can use this same logic here to sort, or this bucket sort algorithm to solving this problem using this bucket sort approach. In bucket sort, we are taking all of the buckets like from start to end. Here we are taking bucket till 0 to n plus 1. Why? Because we have frequency, the maximum frequency that we can achieve is the array size. Okay, that's why we are taking 0 to n plus 1. This is our bucket. For every element, suppose the element frequency is 1, we just put it here, we just 2 put it here, 3 put it here, 4 put it here. So the approach would become first, first, okay, first take this array, make a map, okay, with frequency, like simple frequency map. So 1 has 3, 2 has 2, 3 has 1. Okay, this is our frequency map for this array. Now take one array of size 6, okay, or vector of size 6. So you can just take, let's be just, so take uh, okay, take a array or a vector of size 6. Okay, just put 6 here. So there are total 6, like 0, 1, 2, 2, 3, 4, 5, 6. Okay, everything at the starting initialized with a null pointer. Okay, now 1 has frequency 3, so in the 3 box we just put 1. Okay, 2 has frequency 2, in the 2 we just put frequency 2 or the number 2. 3 has frequency 1, so here we just put 3. Okay, we first we get the array, we make a map according to the array. For the map we are using this array to just store all of the things together. Okay, after this, if we just traverse the array from the end, okay, and wherever we don't find any null, these are all the null values or the zero value, whichever you want. So we just check, does any element here? No, it is null. Skip, null, skip, null, skip. Yes, element here, 1. Okay, again go here, 2. Okay, one element here, 2. We need 2 element and we get 2 element. Okay, this is good. This will be our approach. We will use a map and then use an array to store all the element using bucket sort. And the main thing about bucket sort is, on average, the bucket sort take big O of n into k. N is the size of the array and 10 into k, not n into k. Bucket sort doesn't take n into k. So in our regular sorting, we are having around big O of n log n time. So in bucket sort, the the complexity become n plus k. So n would be the size of the array, k would be the size of the bucket. So here the size of the array n, and we just take the bucket size k as n plus 1. So what will be our complexity? Big O of 2n plus 1. We just ignore this integer value and the time complexity would become big O of n. So it is better than big O of n log n. Because of this bucket sort, we are using the bucket sort approach. Okay, so just go here and visualize it, the bucket sort. Okay, so first we are given a k and a count. Count is simply the map which we store the value and the frequencies. I0, value 1, count of 1 equal to 1. We just increase it. Similarly, we increase it here, increase it here, increase the 2, the 2, the 3. So this is our frequency map, hash map, whichever you want to call. This is our frequency map or hash map. 1 is the value, 3 is the frequency of that value. Then we just store everything in a bucket. F of 3 1, f of 2 2, f of 1 3. So bucket 3 contains element only 1 because the 1 already present in the map with the frequency 3. For this reason, the bucket 3 contain only 1. Similar for bucket 2, similar for bucket 1. Okay, this is our bucket. Then just go down into the buckets from the end to start. From the end to start. Here we just from the end to start. Why end to start? Because we want the element which are having maximum frequencies. Maximum frequencies we just take. We just do it. So we need a maximum frequencies. That's why we are traversing from the end to start, because the index of this array or the bucket, whichever you want, is actually the frequency number of the element. Actually, whichever element store, like 3 store 1, that's mean 1 has a frequency 3. Okay, then just result would be 1, then 2, simply k will be 2. Okay, we just add it. Just now write the pseudocode here also. First we just take simply a function, is array and k. So array is the array and k is the number of element which we need. A simple map, count, whichever you want. A empty hash map which is consists nothing but value comma frequency. Then just traverse the array from the starting to the end index and store everything into value comma frequency map. Okay, now create a bucket of f. Okay, what is the f here? F here is the frequency. So store element with the frequency of f into this bucket. Okay, so elements with frequency f, and f start from 1 to n. 1 to n, that is the 1 is the minimum frequency, n is the maximum frequency. Okay, now create a result or an answer which is a vector, obviously. Now from the ending to the start, from the endings to the start, from the end down to 1, from the ending to the start, add everything into the bucket, everything into the bucket to the answer until we reach k element. Bucket of I to result or the answer until the, the size of the result. The size of the result is equal to k. This is used for the size of an element or a vector or everything. For the size we are using this bars, and then just return the that, take it, evaluate it. Okay, we solve it. Now write the code here. So this is our code. First take the size int n equal to nums dot size. Okay, and take a map, an ordered map. Take an unordered map or an ordered map, anything you want, of map for every element. For every element, just go and add everything into the map, the value and the count. So nums of I plus plus. Now for this case we need to create a bucket, and here the bucket would be a vector of vector. Why a vector of vector? So this is considered an array or vector. Here we can also have like a 4, like a 5. We can have multiple uh, values with multiple frequencies, or multiple values with same frequencies. We can have both cases. So we just have to put everything into a vector, so that if the frequency of 4 and 5 is also 3, we just have to put it here like in 3, so that every whenever we just come and check for the values, we for the maximum index we can get all the 3 values. So for that reason we have to take a vector of vector, which is obviously an integer, because it is an integer array of frequency, vector of frequency. Now, or rather than frequency, call it bucket, because we are using the bucket sort. Now just put all the element from the map to the bucket. So for auto it map, take every element from the map. How we store it here? See it here. The frequency are the index, and the values are inside that index. So the bucket of the second, because the second has the index, is equal to the first value. So if multiple values stored into the element or the index 3, then we just every time we just take the frequency and just take the frequency from the map, check where the frequency lies into the vector, which is the index, and then put the value inside that index. Okay, we have to perform this form this. So now we have now we just go and search for element like until we reach k. So from the end to the start, or one thing I missed, we have to initialize the size with n plus 1, otherwise it may not work. So starting from n 1, because 0 in the 0 frequency is not possible, take every element. Why? If every element of that bucket. So what we have to check now? First we have to check if the bucket of that index is null or not. Is it null or not? Okay. So for that we are using a if condition which says bucket of I dot size. So we just take the bucket of I dot size. If it becomes 0 anytime if the bucket of size 0, that means we are having this null here or no values, we just use a cross here. For this reason we just simply say continue. So skip this and go to the next element. So when we have to go to the next element, so if we have like 145, everything has frequency 3, we have to pick two elements, k is 2. Okay, how do we pick? Okay, from here just pick two elements. From these three, pick two elements with the most frequency, that is 4 and 5. Okay, so for that reason we have to perform another loop here which says bucket of I dot size is greater than 0 and k is greater than 0. Why k is greater than 0? Because if k is become 0, then we don't need to take any values, and also we have to create an answer here, answer or a result. So just go there and first push back all the bucket element to the into the result. So result dot push back the bucket of I on that index, the last of the back element. So from the end, so here we need to clear it. So if a 5 will also be here, we have to take element from the backwards to forward. That's why we are taking this back. So this back ensure we take the last element. Okay, so after taking the last element, what you have to do, we just remove that element. Why? Because if we want to just like two elements, so we come here at the first, and if we don't remove it, we again come to 3 because 3 is till now not 0, and we need one more element because k is 2. Already we take 5, so we come here and take one more element, and that is also become 5. So that's not possible. So first take and bucket of I dot pop back. So this pop back function will go and remove the last element, and at the end just remove the k by 1. That is it, and here just return the answer. Okay, inverted semicolon. Okay, okay. Spelling mistake. No available. Okay, sorry. So this error occurs because this bucket of it dot second is the value here, and it take only a vector. The value inside this index 1 is a vector, so we cannot use any kind of equal to. Here we have to use pushback. So at the end we just push this first element, so we have to use pushback here. After result, this should be answer. So in the answer we have to push, not the result. It's working. Let's submit it. Okay, we completed it. In this solution, we just use up the bucket sort approach here. There is two loop, but this loop only works till k is greater than 0, which is a linear time complexity. Okay, after this loop k is here, we just cannot perform anything here. So it will take a big O of n plus k, and the k is nothing but n plus 1, which is the bucket size, and at the end it become O of n at time complexity, and the space we are also use is become O of n, because we are using this map and then is this bucket. But also at the end we are just removing element from this bucket. Major portion we remove according to kth portion. So we can say that the time complexity is big O of n, also the space complexity is big O of n. That is it for this question of frequent k element. Go check this visualizer, use this link here, use this link to get a 7-day free trial. Go check the visualizer at dsa.chaicode.com. Thank you.